Good morning students, myself Dr. Vishwanath CC, Assistant Professor, Department of Chemistry, GSS, Arts, Science and Commerce, Degree College, Gokak. This college is affiliated to Rani Chennamma University, Belagavi. In previous video, we studied expression for half-life period of a second order reaction and determination of order of reaction. In that we studied half-life period method. Today we discuss differential equation method. Differential equation method is also called as Van 't Hoff's method. In this method we determine the rate change in concentration of reactants or products with the time, that is dC divided by dt, by measuring slopes of concentration C versus time t curves. For nth order reaction, the equation is given by minus dC divided by dt is proportional to C to the power of n. Here minus sign indicates that decrease or disappearance in concentration of the reactant with the time. Remove the proportionality, put K as a rate constant. What happens? The equation minus dC divided by dt equals Kc to the power of n. For concentration C1 and C2, we have, for concentration C1, the equation is minus dC1 divided by dt equals Kc1 to the power of n. This is equation number 2. For concentration C2, the equation is minus dC2 divided by dt equals Kc to the power of n. This is equation number 2. Divide equation 1 and 2. What happens? The equation minus dC1 divided by dt divided by minus dC2 divided by dt equals Kc1 to the power of n divided by Kc2 to the power of n. Here Kk has been cancelled. What happens? The equation minus dC1 divided by dt divided by minus dC2 divided by dt equals C1 to the power of n divided by C2 the power of n. Here n becomes common. What happens? The equation minus dC1 divided by dt divided by minus dC2 divided by dt equals C1 divided by C to the power of n. Taking logarithm on the above equation, what happens? The equation log minus dC1 divided by dt divided by minus dC2 divided by dt equals log C1 divided by C to the power of n. The power n becomes downside. What happens? The equation log minus dC1 divided by dt divided by minus dC2 divided by dt equals n log C1 divided by C2. Here log C1 divided by C2 will comes left hand side. The n value, what happens? N equals log minus dC1 divided by dt divided by minus dC2 divided by dt divided by log C1 divided by C2. Then what happens? The equation n is equal to log minus dC1 divided by dt minus log minus dC2 divided by dt divided by log C1 minus log C2. This is the n, that is order of reaction, has been calculated by this equation. Next we will come to the problems on second order reaction and half-life period. First we will see the second order reaction problem. A second order reaction with A equals B is 20% completed in 500 seconds. What is its rate constant and how long will it take for 60% completion? Here two steps will be calculated. One is K value and another one is time. First we will calculate K value. What are they given? A equals 100, x is equal to 20 and t equals 500 seconds. Put second order reaction formula. K equals 1 by t into x divided by A into A minus x. Next step, what happens? 1 divided by 500 into 20 divided by 100 into 100 minus 20. Here 100 minus 20 is 80. Next step, what happens? 1 divided by 500 into 20 divided by 100 into 80. Here 20 ones are 20, 24s are 80. What happens in next step? 1 divided by 2 into 10 to the minus 5. In next step, what happens? 1 divided by 2 gives 0.5. That is what happens, K value, K is equal to 0.5 into 10 to the minus 5 mole inverse liter second inverse. This is the K value. In next step, what will be calculated? T value, that is time. What are they given? A is equal to 100, X is equal to 60, K has been calculated, K is equal to 0.5 into 10 to the minus 5 and T must be calculated. What happens? The formula of second order reaction, T is equal to 1 by K into X divided by A into A minus X. Next step, what happens? 1 divided by K value has been calculated, 1 divided by 0.5 into 10 to the minus 5 into 60 divided by 100 into 100 minus 60. Next, 100 minus 60 is 40. In next step, what happens? 1 divided by 0.5 into 10 to the minus 5 into 60 divided by 100 into 40. 23 is 60, 22 is 40. What happens? Next step, 3 divided by 200 into 0.5 into 10 to the minus 5. Here 10 to the minus 5 will be goes upside, minus will becomes positive. 3 into 10 to the power of 5 divided by 2 in 200 into 0.5 is gives 100. By dividing 3 divided by 100, it gives 0.03 into 10 to the power of 5. Then the T value is T equals 3000 seconds. This is the problem of second order. Here K has been calculated and T also has been calculated. And next we calculate, the next problem is the rate constant for a second order reaction is 3.33 into 10 to the power of minus 2 mole inverse liter second inverse. If the initial concentration of the reactant is 0.05 mole inverse liter, calculate the half-life period of the reaction. Here T off must be calculated. What are the given? K is equal to 3.33 into 10 to the minus 2 mole inverse liter second inverse and A equals 0.05 mole inverse liter. What will be calculated? T of must be calculated. Put T of formula. T of is equal to 1 divided by Ka. In next step, what happens? 1 divided by 3.33 into 10 to the minus 2 into 0.05. 3.33 into 0.05, it gives 0.1665 into 10 to the minus 2. What happens? 1 divided by 0.1665 into 10 to the minus 2. Here 10 to the minus 2 will goes upside. What happens there? What happens? Minus will becomes positive. What happens? 1 into 10 to the power of 2 divided by 0.1665. 1 divided by 0.1665, it gives 6.006 into 10 to the power of 2 minute. This is the T of a second order reaction. These are the problems on second order reaction and T of, that is time, half-life period of a second order reaction. In next class we studied collision theory, that is simple collision theory. Thank you.